Hi students. So in the previous class we finished electrostatic potential energy, all those concepts behind electrostatic potential energy. We finished its definition. We just calculated how to find the electrostatic potential energy for a given system of charges, and we also found out the electrostatic potential energy for a dipole which is kept in a uniform electric field, and so many things. So today, since it is a very important thing, we shall try to do some problems today, not more than 2 3 or 4 problems. So let us try some problems. I'll give you the questions, and just try to solve them according to the method. So then we will solve them on the board. Okay. So let me check if it is working. Yes, it is working. So the first question is yes. So what is the first question? So what is the we are going to start from the basic concept of the problem, which we are going to do a numerical regarding the basic concept. Okay, what is the electrostatic what is the electrostatic potential energy? What is the electrostatic potential energy of a system of two charges? Okay, there is a system that consists of two charges, that is 5 microcoulomb and -4 microcoulomb. This is the system that is asking you to find the potential energy of two charges kept at a separation of 2 meter. Okay, so you have been given the question to find out the electrostatic potential energy of a system of two charges. So your system basically consists of two charges. What are those charges? One is 5 microcoulomb and the other is -4 microcoulomb, and they are separated by a distance 2 meter. So in this thing previously, we didn't mention about the negative charge. Okay, we described about the negative charge, but in problems we didn't took care, or we didn't take care of that negative thing. Okay, but in this type of problems we have to deal carefully regarding these positive charges or negative charges. So according to the given data, so you are going to write, given your q1, the first charge is 5 microcoulomb, that is equal to 5 into 10 raised to the power minus 6 coulomb, and q2 is -4 microcoulomb, and it is -4 into 10 raised to the power minus 6 coulomb. Okay, and what is the distance? Distance is 2 meter. So you need to find the electrostatic potential energy of that system. So as you know, electrostatic potential energy is given by U is equal to 1 upon 4 pi epsilon naught multiplied Q1 Q2 upon R. R is the distance of separation between them. Just use those things into this formula. As you know that 1 upon 4 pi epsilon 0, the value is 9 into 10 raised to the power 9. Okay, now put these things in their places. What is q1? Q1 is 5 into 10 raised to the power minus 6 multiplied. What is q2? So it's important that you mention the negative thing also. Minus 4 into 10 raised to the power minus 6. Okay, so at last you mention the unit of energy divided upon what is R. R is 2. Okay, so this is our answer. Just try to solve it. So what will be the answer? 9 times 5, that is 45, into 2, that is minus 90, into 10 raised to the power 9, minus 6 and minus 6, they give you minus 12, that is minus 90 into 10 raised to the power minus 3 joules minus 0.09 joules. This is your answer for the system. So this much of energy has been consumed to keep these charges apart from each other by a distance of 2 meter. So in this case you get a positive charge and a negative charge, but it can also be given that here it contains a positive charge, it contains a positive charge, or it is a negative charge and the other charge is also a negative charge. There is no restriction. So if you are given like many charges, like more than 2 charges or more than 3 charges, so consider these things, that q1 is given, q2 is given, and q3 is given. Okay, and the relative distances are also given. That means the distance between q1 and q2 is also given, q2 and q3 is also given, and q1 and q3 is also given to you. So you need to find the electrostatic potential energy for this pair, then this pair, and then this and this pair, and then add them. And due course you have to watch out for the negative side. Okay, for the negative sign of that charge. And after that, when you find out all of them individually, you just add them algebraically. If the electrostatic potential energy of this system is 1 joule, of this pair is minus 2 joule, and of this pair is 3 joule, then you just add them like you add numbers. 1 plus 3 gives you 4, and 4 plus minus 2 gives you 2 joule. So electrostatic potential energy for this system is 2 joule. So it is that simple of a problem. Okay, so we shall be proceeding to another problem, and I hope that you have understood the concept behind these problems. Okay, so let us do another problem. So in the previous problem, I just forgot to tell you one thing, that our potential energy was calculated to be 0.09 joule. Okay, this is the energy of that system, the electrostatic potential energy of that system. Now let us imagine that you are going to separate them. You are going to send the positive charge to infinity and the negative charge to infinity. That means there is now infinite distance between them. So how much of work is needed to separate them and send them out to infinity? So how much work is needed? It is minus u. Okay, so minus of minus, it is 0.09 joule. And if you apply this much of energy, or you give the system this much of energy, they'll be separated out to infinity. Okay, or to bring them into infinity, to that portion of that space, you will be doing this much work. Okay, so now we proceed to another problem. So what is the problem? It is a conceptual problem. It is given that a charge plus q is placed symmetric is placed symmetrically between the line joining two equal negative charges. Okay, two equal negative charges. If the electrostatic electrostatic potential if the electrostatic potential energy if the electrostatic potential energy of the system is zero, then find out find out the relation between Q and Q. Okay, so it is given that, and this negative charges is Q. Okay, this negative charge is small q. Negative charges equal negative charges minus q. So you need to find out the relation between q and small q. So just follow the method that you have known earlier. So just try to visualize it and draw a diagram. So there is a system that consists of two charges minus q and another charge plus q is placed symmetrically in between those two charges. So, and it is given that the electrostatic potential energy for that system is 0. Okay, so the condition is U is equal to 0 for this system. The electrostatic potential energy for this system is 0. So, how are you going to find the relation between Q and small q? Okay, so first of all, you have to keep it in mind that Q is placed symmetrically in between those two charges. That means if this distance is R, then this distance is also R. And now just name them. This point is A, this point is V, and this point is C. Okay, so you need to calculate the individual electrostatic potential energy of those pairs. Just find those pairs. What are those pairs? One pair is Q and plus Q. These two pair, and these two make a pair. And the other is plus Q and minus Q, and the other pair is minus Q and minus Q. These are the three pairs you have. So for the first pair, you find U1. So what will be that answer? 1 upon 4 pi epsilon naught minus q into plus q divided by AB. What is the distance? The distance is R. Okay. Now find U2, the electrostatic potential energy for this pair. So it is 1 upon 4 pi epsilon naught plus q, then minus q. What is the distance between this charge and this charge? It is R. So divided by R. Now find U3. What is U3? The electrostatic potential of this pair that consists of both the negative charges. That is 1 upon 4 pi epsilon naught minus q into minus q upon 2r. Okay, upon 2r. The distance between those negative charges is 2r. So at last, since these are all scalars, they are constant things or they are numbers, you can add them. So the total potential energy of that given system is U is equal to U1 plus U2 plus U3 is equals to 0 as per the given condition. Okay, since U1, U2 and U3 have all of them have a common thing, that is 1 upon 4 pi epsilon naught. So you can write as 1 upon 4 pi epsilon naught. Just try to multiply them. That is q. Okay, this and this multiply to get q minus q and q divided by r. Then this thing also q and plus and minus is minus q by r, and minus q they get multiplied to get q squared upon 2r, and this thing results into 0. Okay, now we need to eliminate these things. So what do we get? These things get to that side and we get a 0. Now we have this thing. So just do the operations. So what is the operations? So let me proceed to the right. So the operation is, this thing is 0. See, minus q by r minus q by r. They are similar things. So you write minus 2q by r plus q square upon 2r is equal to 0. So this is the answer. You shall be proceeding. So just take these things to this side. Q squared upon 2r is equal to 2q by r. Just try to eliminate these things. 1r and 1r get eliminated from both sides. 1q and 1q get eliminated from both sides. And when you try to find q, you get 2 gets multiplied to this side, that is 4q. This is the relation between the small q and capital Q. Okay, this is your required answer. So it may be given in the form q is equal to q by 4 and this form. So you need to check it carefully in the options that what is the perfect answer. Okay, so it can be given like this or given like this. And after that it can also be naming if at last you find that relationship, and at that point it is asking that if q or the capital Q is 1 coulomb, what is the value of small q? So you get these things, multiply the thing for on the LHS, you get that small q is 4 coulomb. So at last from this problem we have understood the concept that even if we are going to calculate the potential energy of a given system, we are going to consider the pairs. We are going to consider the pairs first. This charge and this charge makes a pair. This charge and this charge make a pair, and these two charges make a pair. So we calculate the electrostatic potential energy for those pairs individually, and then after that we add them. After that we add them, and we find the answer. So if the relation or the condition has not been given, we have to stop at this point of time. Okay, as the relation is given that it is 0, so we could proceed further. So let us, I hope you have understood the problem. If not, you can comment in the comment section. So let us jump to another problem. So at this point, I stop the lecture today. We shall be continuing the lectures as potential electrostatic potential is over. We shall be jumping to capacitance, but before that you need some introduction to capacitance. So what is it, or why is it important? What is the applications? What is its applications in physics? And every bit of thing you need to know about capacitance. Okay, and potential and capacitance are connected things. So up until then, try to practice more problems. If you have any doubt regarding numericals of this chapter, you can actually drop those problems in the comment section. And also I have given my contact details in the description box of every of the videos. So like our lectures, subscribe us and share it among friends. Okay, take care then. See you. Thank you all.